So our next presenter from Dimensional Mechanics is Rajeev. Please give him a wonderful welcome. Thank you, Rajeev.
Okay, so building ML for fun and profit is kind of what we do as a company. So when I was about 13 years old, my mission in life was to see robots everywhere. I kind of realized at that point I really liked robots. And so our company has evolved, and it's not about robots, it's just about AI. And our mission is to make AI very easy, and we want to see AI deployed everywhere. There was an article that was recently written about us where somebody wrote that we're the company most likely to invent Skynet. I'm not sure whether I truly appreciate that, but there you go. So working with AI and building AI is a little bit like chipping away at a 10-meter, I'm Canadian, so I use metric, 10-meter thick wall. And so the reason for that is just it takes a lot of time. You require specialty tools, and it's also a lot of effort. Add to that specialist skills, and so I don't know whether it requires specialist skills to break through a wall, but there you go, maybe the right point, pressure point or something. So with all of that together, it's a huge effort. So the second issue is that there's an ROI issue. So if a company invests in AI, just how much of an effort is worth it? I mean, if you hire ML resources, you spend months trying to develop something, are you actually going to get something out of it? And if you're going to spend time actually iterating on a machine learning model, you're going to run into some ROI questions. In fact, majority of our customers, that's the first question that they ask, is what's the ROI in investing in AI? So we want to kind of help them by answering this question. We're able to cut down, in some cases, our company can cut down the cost of AI by around 90%. So we had one startup that was quoted $360,000. We brought it down to about $5,000. So that was pretty cool. So for those of you who do machine learning, you should probably recognize at least some of these. These are all the different frameworks. And these frameworks are, the majority, I think the biggest one is TensorFlow. At least most people I know who are in the field have at some point worked with TensorFlow. But the problem is that you need a way for us to, just one way to do it. Instead of 20 million different ways to do AI, is there a single way? So this is what we set out to do, is to kind of one ring to bind them all, hopefully not in darkness. Then the second part was about building. So what we did was we built the NeoPulse framework. So NeoPulse, it turns out that there's a chain of luggage by Samsung called NeoPulse, but we discovered that later. So the NeoPulse framework is what we have. It's available on AWS, so if you want to try it out. So the NeoPulse, the core part of this is something called AI Studio. And now I'm going to make this is where Terminator comes in. Because behind AI Studio, there's an AI. And so literally what you have is an AI that builds AI. And interesting factoid, AI Studio builds AI Studio. So we actually use the AI behind AI Studio to build itself. So there's kind of a bit of a meta thing there. So it's pretty cool. We call the thing the Oracle. Matrix reference, we are geeks. The output for AI Studio is something called a portable inference model. So portable inference model, what this means is that you can deploy our solution anywhere. You can be on-premise, you can put it in the cloud, you can also put it in IoT devices. This is a big thing, and also in mobile devices. So we're currently investigating the use of our platform, our runtime, on being able to deploy our AI on Android phones. So this is actually pretty cool. In order to do this is you need our runtime. So our runtime, think Java. So you can think about our PIM as a Java binary and the query runtime as our runtime. And so you need the runtime in order to access the PIM. What the runtime does is it automatically generates a REST interface so that you don't even need to worry about that. It's like AI Studio will automatically generate a portable inference model for you. And once you've generated the PIM, you dump it into the runtime. The runtime will automatically generate an interface. So this is the lazy man's way of doing ML. The last part is we created a new language called NML. So the cool thing about NML is that we like to compare it to SQL because it is a language that is designed for deep learning. It simplifies things dramatically so that within about 14 lines of code, you can build a full classification model for audio, video, text, numerical data, you name it. And it's also very readable, so you can actually look. It's something called a pipeline that allows you to kind of like do this. So it's pretty powerful. So I'm going to show you how to use that. So this is the workflow. You have your data, and you have your NML file. You submit that to AI Studio. AI Studio will compile it and will generate the PIM. So once you have the PIM generated, you can export that, and you can put that into the runtime. And what the runtime will do is that you can it'll automatically generate the interface, and from then on, it's accessible to anything in your company. Back. Okay. So here's a medical case. In fact, Stanford is currently using us in their medical program, so this is kind of a cool project. This is with X-rays, but they're using it in a more complex way with CTs, which is a three-dimensional scenario. But let's start with two-dimensional. And so we've got with tumors, without. You construct a very simple CSV file, 0 for without tumor, 1 for with. Here's your NML code. So 14 lines of code. I don't know whether you guys can see it. It's kind of hard to see. So the guys in the front row probably can. But 14 lines of code, pretty much what that does is that it'll automatically, we have a way to optimize memory management, so we stream it from disk. So, which means that we take all of your images, we'll automatically stream it from disk, produce a structure that allows you to then build up a machine learning model. We introduced a keyword auto. So whenever the compiler sees the keyword auto, it makes a decision that, hey, you don't know what you're doing, so I'm going to actually ask the Oracle. And the Oracle will build the model for you. And so the Oracle basically selects the best architecture. It also picks the best hyperparameters to go along with that. And we recently updated the optimization mechanism so that we can now mathematically prove that we will be able to outdo any human being. So we will definitely, so I challenge people to use it and see whether you can actually beat it. Boop, 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 boop. All right, so we're almost out. So basically you submit it for compile, you train it. This is the time-consuming piece. You export it, which is what I talked about in just a moment. It's very easy. It's a very simple command. You import it into the runtime, and you now make it accessible to applications. The one elephant in the room, which you heard about earlier, is data. And by the way, I love this picture. I have no idea why, but it's like 2010 or 2001 or something. By the way, my references to Terminator and HAL are kind of, it's not as scary as that. We're not that bad. But you heard about the mechanical Turk issue, that's a huge advantage for this. But data is going to be an ongoing issue, so preparing the data. We do actually some work in that space. We're starting to expand so that you can actually help structure your data and also manipulate your data so that it's ready for machine learning. But of course, you need the underlying data to begin with. So, mechanical Turk. All right, with that, I'm done.
Questions?
With an infinite amount of processing power, you can always find the optimal solution to a problem. How do you find an optimal solution to model building with an infinite amount of processing?
So that's basically where our AI that builds an AI comes from. It actually has logic built into it where it learns from its previous attempts. So it actually, over time, it improves and gets better and better at its job. And so we have introduced recently some logic to actually improve on the architecture as well. So it learns how to do things better every time. And it converges on the optimal solution much faster than infinite. Yeah. So just programming versus AI? Well, AI is just, I mean, the high-level word, you can make any application reasonably intelligent, and you can do that procedurally. What we do is primarily deep learning. So it's machine learning. So it's a branch of deep learning is a part of that. There's something called the universal function approximator theorem, which basically says that if you have any sort of machine learning problem, you can map it onto a deep learning problem. So we kind of have a catch-all bucket so that we solve everything.
Okay. One more question.
What is your primary customer?
So we started with media and entertainment. We have every group. So the Stanford case, we actually had a doctor who knew nothing about machine learning. So she's smart, but she's not a machine learning person. She's not even a software engineer. And she was able to build a model like within a weekend. So that was pretty good. On the other hand, we have some very sophisticated machine learning people. Like we just finished a project with a hedge fund. And these guys know what they're doing, and they actually used NML in its not so pure form, so they didn't need to use Auto as much. Although I kind of dared them to kind of beat what Auto does, but they're a hedge fund, so they need to know how things work. So, all right.